And this topic deals with remediation of soil by solidification. So, remediation techniques. The first method is solidification. Let us go into the method. So, first, it is used. This technique is used to stabilize and immobilize contaminants in soil by incorporating them into a solid matrix. That it reduces. This method reduces the leachability and mobility of the contaminants, and this we have seen in the previous unit itself, that is in the unit known as waste stabilization. Okay, so how, let us here see how the contaminated soil remediation by solidification typically works. First is soil characterization. So to understand the type and concentration of contaminants present, we have to choose a suitable solidification agent and treatment parameters. And next one is selection of solidifying agent. We have to choose whether cement is applicable, lime is applicable, fly ash is applicable, polymers are selected based on the ability to chemically bind with contaminants and form a stable solid matrix. And next one is the mixing and blending. Here solidification agents are then mixed or blended with the soil using mechanical equipment such as excavators, mixers or plug mills in a contaminant vessel. And these are the process which are taken, and then the chemical reactions takes place. It occurs between the contaminants and the agents, resulting in the formation of an insoluble compound or complexes. These reactions immobilize the contaminants with the solid matrix and reduce the solubility and immobility. And after that, solidification and curing, we have to go for curing process. The treated soil is allowed to solidify and cure, typically through hydration or chemical curing processes. After that, we have to go for quality control and monitoring. The quality control measures are implemented to ensure the effectiveness of treatment and compliance with the regulatory standards. We all know, I have already told about compliance with the regulatory with the standards. And next one is monitoring of key parameters such as pH, moisture content, and leachability of contaminants helps to verify the success of solidification remediation. And next one is the post-treatment assessment. To evaluate, this is done to evaluate the effectiveness of remediation and verify that the cleanup goals have been achieved. So each step should be carried out with utmost care. And let us see about the advantages of solidification. It is helpful in reduction of contaminant leachability and mobility, stabilization of contaminated soil for safe handling and disposal, enhancement of soil strength and stability, compatibility with the wide range of contaminants and soil types, cost effectiveness compared to excavation and off-site disposal. However, solidification remediation may also have limitations such as potential for long-term durability and effectiveness, need for careful design and implementation to ensure proper treatment, potential for volume increase due to addition of solidification agents, and next one is potential for generation of secondary waste streams, example waste from excess solidification agents. So equally there are advantages and disadvantages, but depending upon the nature of the contaminant, the method of solidification can be chosen. And next one is the bioremediation process. So bioremediation means a sustainable and environmental friendly approach that utilizes microorganisms, plants and the enzymes to degrade, detoxify or immobilize contaminants. Here also we have seen already about this bioremediation as biodegradation, phytoremediation, etc. So the same thing I think we are going to continue here also. So here first we have to go for the characterization. We have to find out what type of contaminants are present in the soil. Then we have to choose the bioremediation strategy, which method, either we have to go for composting or a biodegradation, or we have to go for vermicompost or any other strategy. We have to find out that strategy which can be adopted. And third one is the biostimulation, enhancing the growth and activity of indigenous microorganisms. So here for the bio decomposition or biological remediation, we have to go excess of stimulants can be grown, so which we have to choose the those organisms. And next one is bioaugmentation, introducing exogenous microorganisms like bacteria and fungi or microbial consortia to the contaminated soil. And next one is the fifth one is the phytoremediation, which is already we know it is using plants to uptake, metabolize, or sequester contaminants from soil through the process of phytoextraction, rhizodegradation, and photostabilization. And next one is the application of bioremediation amendments. So we are going to we are going to add certain nutrients and microbial inoculants for the process of amendment or remediation. And next step may be the monitoring and optimization. This is to conduct it assess the effectiveness of the treatment. And next one is evaluation of treatment effectiveness. So we are going to analyze we are going to analyze it to evaluate the treatment of effectiveness and verify whether the cleanup goals have been achieved. So what are the advantages of bioremediation over traditional methods? It is sustainable. It's a very sustainable method. It's a cost-effective method. It is environmentally compatible. And what are there may be limitations also. A few of them are. It is quite a time-consuming process. We have to consider the site-specific factors like type of soil, contaminant type, environmental condition, and microbial activity. And also we have to go for, before going for this process, we have to go for regulatory approval, because we are going to add some modified agents, inoculants, or exotic organisms into the soil, which may harm the environment or the soil. So we have to go for regulatory approval also. And I hope you all have understood about bioremediation as well as the stabilization. Thank you for watching.